Hello, welcome to my presentation. My paper title is Automation of 5G Network Slicing Security Using Intent-Based Networking, IBN. And as I am the first author, let us introduce with the authors of this paper. So these are the introduction of the authors. The first author, myself, MD Zahirul Islam, as a PhD researcher in Joshua University of Science and Technology, Bangladesh. Then second author is Dr. Syed Galib, Professor and Chairman, Department of CSE, Joshua University of Science and Technology. Then Dr. Humaun, Kabir, Assistant Professor, Department of Physics, Joshua University of Science and Technology in Bangladesh. So at the very outset, I would like to discuss about the outline of the presentation. So at first, I would like to start my presentation with the abstract, then introduction, later on literature review, followed by methodology, then DDoS attack and its mitigation. After that, spoofing attack and its mitigation, then proposed framework, experimental description, result analysis, and the conclusion. So this will be the overall outline of my presentation. So in the abstract, I would like to summarize my whole work like this, that I am working on the network slicing security. So network slicing is basically a fundamental technological advancement that facilitates the provision of the novel service and solution of 5G network communication. But the problem is that numerous challenges emerge when we would like to implement the network slicing on a large scale commercial level. Since it necessitates comprehensive control and the automation of entire network, then kind of intent-based networking can be used to identify and address such kind of challenges in an automated way. The challenges which can be mentioned like this, the prominent cyber attacks such as distributed denial of service DDoS or address resolution protocol ARP, which is significantly disrupt the performance and accessibility of the slice in a multi-tenant environment. So in order to address and resolve this issue, we can use the intent-based networking, which can give solution of this kind of challenges in an automated manner. So in order to do this, a conceptual framework is presented in this paper where the IBN manager is integrated into a network slicing architecture to facilitate the implementation of the automated security control. Then that proposed work is assessed with an experimental test bed and compared with the general framework for the performance analysis. And this performance result is found that it has been improved in various metrics like availability, packet loss, response time, CPU, and memory utilization. Then in the introduction part, I would like to say about the network slicing. Basically, network slicing is a groundbreaking concept that allows for the creation of the mobile network as needed. The fundamental concept of the network slicing is to cost-effective operation of multiple virtual network on a shared physical infrastructure. In here, we can say that network slicing is a term which is described as the division of the physical layers into several virtual network, which can be the cost-effective, and this virtual network can be tailored and optimized for the particular application or the subscriber. Here we can see the network slicing overall architecture where three layers are mentioned here: network service layer, network function layer, infrastructure layer, and these three layers is controlled by the network slice controller, which is known as the network orchestrator. So this is the network slicing, and this network slicing is enabled by the combination of the network function virtualization (NFV) and software-defined networking (SDN), which is highly advantageous approach for the telecommunication operators. So this is basically the overview of the network slicing. Next, we would like to go in the literature review section where several researchers' their contribution and findings is been summarized in a tabular format. The paper from 2017 to 2024, almost was a few papers has been listed here where their contribution and remarks has been mentioned. I hope you can go through the paper and you can learn about this contribution and the improvement factors. I would like to mainly focus in this presentation how I get this result and how this has been maintained. I would like to highlight this portion. So I'm skipping this literature review part as it is mentioned in the paper. Okay. Next, how we can do this research work. The methodology has been shows these ideologies. In here, we would like to develop the conceptual framework with the intent-based networking manager or IBN manager, which is integrated into the network slicing architecture for facilitating the implementation of the automated security control. And next step after this conceptual framework design, we will address some issues of the cyber attack like distributed denial of service attack, DDoS, and especially focusing on the TCP flooding and ARP spoofing through the implementation and experimental text bed. And finally, we will compare the proposed model performance with the general network slicing architecture with the parameters of the availability, packet loss, response time, CPU, disk, and memory utilization. Okay. The next slide is describe about the DDoS attack detection and mitigation method. In here, we are going to describe how can we detect and mitigate the DDoS attack. So the prominent method in order to detect the DDoS, that is the entropy. Entropy denotes the randomness of the network incoming packets and how it can be equally distributed throughout the network. SDN switch or software-defined network switch basically calculates the entropy based on the incoming or outgoing traffic flow or the statistics. In here, two parameters are required for the DDoS detection. One is the window size, which is basically the time period or can be the number of packet. And another one is the threshold value. So entropy is calculated in this way that that window is measured the uncertainty. And the calculation is like this, the calculated value of the entropy. If less than the threshold value, then we can say that DDoS attack has been detected. And how we can basically choose the measure the randomness using the entropy. But the formula and a flowchart has been mentioned in the paper. In here, we just show the experimental description part. So in order to do that, we use some simulation tool like Mininet, where 64 host or 9 switches is been used. Then we use the POX controller, which is Python-based HDN OpenFlow controller. Then we use the Scrappy tool, which is basically fabricate the IP packets to emulate the real traffic. Then we use the SFlowRT, which shows the real-time analytics of the software-defined networking application. These tools we need to use for the simulation. Then a Python script is been developed, which basically launch the traffic code in the simulation environment, where basically a host or computer is sending the packet to a particular destination network. This traffic code is basically denotes this. After that, the attack code, that means a particular host or several hosts, which generates the DDoS attack to particular server or particular machine. This is the Python script of launch the attack code. Then this is the DDoS attack detection code or Python script, which is this script is run in the SDN switch, SDN open switch. So that open flow switch detect the DDoS attack based on this detection code. And here is the mitigation code. After successful detection of the DDoS attack, the particular port or particular point from which the DDoS traffic has been coming, in the mitigation code, it has been mentioned that open flow switch stop or block that particular port so that the malicious traffic cannot enter into the network. So here is the result, how this has been generated in a VirtualBox environment. This topology has been designed. Then this mininet service and SFlow service has been generated. And the mininet custom SFlow RT tool has been used, where the tree topologies with the OpenFlow controller is started with this code. And in here, you can see that when we run this code, it automatically adding 64 hosts, then 9 switches, and link has been connected with each other, and the host has been configured. So the topology automatically generated with the 9 switches and 64 hosts. Then we will activate the POX controller. So we use another terminal and write this Python script or Python code to activate the POX controller. So here we can see the POX controller has been connected with the 9 switches. Then in the X terminal portion, we randomly open the 3 hosts in order to launch the traffic code throughout the network. Then we generate the traffic with a node H5, and it is generating the mentioned traffic Python script, and the traffic has been generated, and an entropy calculation has been showing here that it is 1.54. Then from another host, we generate the attack code, and where the attack has been already been generated, and we can see that the value of the entropy is decreasing after launching the attack. So we can see from here that before the attack, the entropy was 1.54, which is equally distributed the network traffic among the hosts. But when the attack has been generated, and after that, we can find the entropy value falls below the threshold level. And here the threshold level is 0.8. So the value is 0.5, which is definitely below the threshold level. So in general, the controller has been showed that DDoS attack has been detected, and this traffic is coming from the port number 1 of the switch 8. So it basically blocked the port of the 1 of switch number 8, so that the network is been saved from the DDoS traffic. So this SDN controller perform this operation in automated way, utilizing the Python script. The second one will be detection and mitigation of the ARP spoofing. In here, this pictorial diagram shows that what is basically the ARP spoofing attack, where the attacker who is basically carrying the ARP method to know the MAC address of the particular IP using the ARP protocol. And he is basically working as a man in the middle of this network. So we know that the prominent attack, man in the middle attack, which is basically start with the ARP spoofing. So after the spoofing, when the third person or attacker is able to learn the address, IP address or particular MAC address of the host, he or she can be the man in the middle attack as a attacker section. So in here, we do this like this way, that we initialize the POX controller similar way. Then we try to find out the IP address of the virtual machine. Then we connecting the network topology to the controller with the POX controller. In here, how we can maintain the ARP cache entries. The code is been mentioned in here. This is how we can maintain the ARP cache entries. Then later on, we check the ping request and we observe that packet in the Wireshark tool. Using the Wireshark tool, we can find the details of the ping request packet. Then we check the IP and MAC mapping from the host using the ARP-A. So using this tool, we can find the detailed address of the ARP, IP address and MAC. Then we start the ARP poisoning from another host. That means with the information of the previous slide that we collect the IP address from the particular machine and also its MAC address. Then we make the poison, like we set the same IP and MAC is another machine so that the poisoning is being started. And then when we starting again checking the packet by the ping tool, and we sniff the poison packet, and using the Wireshark, we can find it shows that there is a duplicate IP address has been detected. It means this is how it shows that another machine is utilizing my IP address and as well as my MAC address to sniff information and to take the access of my internal network. So this is how the ARP spoofed IP address has been detected, and it is been detected in an automated way. And detection is done using the SDN controller, where the Python script is been loaded in the SDN controller, and it shows that ARP spoofing has been detected. And it similar way, it drops all the packet from that particular port so that the spoof cannot be happened. So this is how in both cases, the DDoS and spoofing attack has been neutralized using the automated Python script. So how can we make this automation? The main idea or the motivation is that we can use an emerging technology that basically helps in the deeper level of intelligence and intended intent to replace the manual process of configuring network that reacting with the network issue. That name is coined as the intent-based networking, which is known as the IBN. So this IBN can detect and mitigate this kind of cyber attacks or security attacks in a automated way. So this is a framework of the particular one slice of the network where the SDN controller, where the administrator and other network slices or context has been connected. So in here, we are just adding an additional tool, which is called the Intersband Networking Manager, whose responsibility is to load that Python script automatically in the SDN controller. So with the help of the information or with the help of the that Python script, the SDN controller will be able to detect those attacks and able to minimize those attacks very proficient way. So in order to complete the experimental description, we use a topology where the several components is being used, like first component is required the ONOS SDN controller and its system specification, like operating system will be Ubuntu 20.2, RAM is 16 GB, CPU is Core i5, and SSD is 500 GB. Second component is open source Mano, which is mobile and network orchestrator, which operating system is Ubuntu 18.04, RAM 16 GB, CPU Core i7, hard disk 1 TB, and OSM version 7. Then third component is IBN tool, which is basically a graphical user interface, and it runs on the Windows operating system. Programming language is Python and database MySQL. And for the testing purpose, we choose 8 slices randomly, and each host basically represents one network slice, and which is basically mininet VirtualBox, and operating system is Ubuntu 18 LTS. So this is the experimental description, and you can find the test bed diagram, how the topology is being developed. You can find from this architecture. This is basically my mininet OpenFlow tool, which represent one particular network slice. This is the ONOS, which is Open Network Orchestrator, then Mobile and Network Orchestrator, open source, and then the intent layer where network analytics has been connected, where we can find the information of a particular network slice, like availability, then packet loss, then maybe it's memory, CPU utilization, etc. So these 6 type of information we will get from that IBN tool. This is how the overall architecture has been developed. Next is the result analysis. We can see that this is the modified architecture of the SDN, and we compare this architecture with the similar type of general architecture where this IBN tool is been missing or IBN tool is not used, and basically the automation is not used, but the network analyst portion is still open. So we can compare with the availability with the proposed version, then availability with the general architecture. It means that with intent-based networking, we get one type of an availability report, and without the IBN, we will get different types of availability report. And then we make a comparison between these two availability, which represents this type of result. It basically represents the impact of the availability. And from this figure, we can find out that there are 2 types of data has been showing. The blue color shows that availability without the intent-based networking, and the orange color represents the availability values with the intent-based networking. The horizontal axis of the graph represents the quantity of the network slices. That means slice 1 to slice 8, and the vertical axis reflects the availability proportion according like percentage of the availability. So in here we can find that the availability percentage of slice 1 to slice 6, which is approximately or near aboutly 0, that is indicated it is not accessible. And the cause of this occurrence that can be attributes to a DDoS attack, which is initiated by the specific host from slice 7 to slice 8. And the absence of the security policy resulted in the unavailability of the slice for the tenant due to this attack. And in the second scenario, the implementing the IBN policy, it enables the detection and mitigation of the potential attack. And in this scenario, network slices remain accessible in the tenant, which represent as an orange color. So in order to detecting the mitigating the DDoS attack, additional security risks such as ARP spoofing is also identified and addressed in other network slices. As a result, implementing the IBN policy leads to a comparatively greater availability percentage. Then we will discuss the impact of the packet loss. In here, this figure, we can find that the horizontal axis represents the packet loss of the network slices, and vertical axis represent the packet loss percentage. So in here, we can find that the observed packet for slice 1 and slice 2 are significantly high. The packet loss is significantly high, approximately 100%, which can be attributed to the combination of security attack, DDoS, and firewall policy issue. It is worth noting that these 2 slides are located outside of the LAN confines or LAN area. So the network topology consists of the LAN where the slice 3 and slice 8 are interconnected with each other. So the measured packet loss is relatively minimum, which can be attributed to the occurrence of the ARP spoofing. So based on this figure, it is an evident that IBN security policy exhibit effective detection and mitigation of the security attack, resulting in comparatively lower packet loss compared to the absence of the IBN security policy. And next one is that impact on the response time. This figure is basically represents that the vertical axis represent the response time in millisecond, and it shows that the response, the time is comparatively higher where the IBN security policy is absent, which is nearly 12 milliseconds for the slice 1 to slice 5, and for the slice 6, 7, 8, it is like 11 or 10. But when we apply the intent-based networking security policy in the network slice, the reaction time reaches to 1 millisecond, which is basically denotes, or which is basically matches with the 5G network technology standard where the IBN policy is used. Next is the impact of the disk utilization. This figure represents the disk utilization, where the vertical axis represents the percentage of the disk in here in this graph, which provides an unambiguous evidence that network slices lacking the application of the IBN security policy, which means the blue shades are provide the higher level of disk utilization ranging from 38% to 45%, where utilizing disk space is ranges lower with the use of the IBN policy, which ranges from 20% to 35% overall capacity of the IBN security strategy. So we can see from here that applying the IBN security strategy, the disk utilization has been reduced, where without the IBN policy, the disk utilization is comparatively higher. So it means that the systems or network slices need to deal with some additional packets like DDoS or other spoofing type issues. Next is the CPU utilization. In here, this figure represents the network slice average CPU utilization for the RAN controller. And we find that without the IBN security policy, the CPU utilization is particularly 70%. And when the IBN security strategy is being applied, the security utilization is a little bit lower, like ranging from 50% to 60%. It particularly concerns that the RAN is connected through the eNode B. So the internet access, video calling, and other application which has been utilized. So CPU users is still comparatively high after reduction of the attack, which becomes 45% to 58%. Due to the high traffic, the utilization is much higher. And next one is the memory utilization. Here, in the figure, we can find that without IBN security policy, the graph shows that the memory utilization is much higher, which is basically 35% to 90% of the total memory capacity. But if we apply the IBN security policy, it demonstrates the successful discovery and the resolution of the security breaches, which basically what we can say that it reduced the memory space ranging from the 30% to 55% of the overall capacity. So if the attack impact of the attack is been minimized, so the unnecessary use of the memory can also be reduced. So this is how it shows basically without IBN strategy, the memory utilization is comparatively higher. So we can say at the conclusion that the graphical representation of the various parameters such as availability, packet loss, response time, etc., it demonstrates the notable improvement after applying the security policy in the IBN tool. And with the collaboration of the IBN manager, the SDN controller has the capacity to mitigate the security risk. So the autonomous policy-based network slicing architecture offers comparatively better performance due to its rationale. And we can say that the extensive 5G, we can say that the test result for these various parameters, the effectiveness and capacity to manage the growing demands of the 5G network slicing technologies. And so this is the reference of this paper. That's all from my presentation. So thank you very much.